I wanted to do one review video on an experimental design problem. So even though this is something that most people typically do okay on, I did have a lot of questions about this one just because it's been so long. So I wanted to go over it. So this is the one on the experimental design packet about getting colds and vitamin C. So the first part that a lot of people were asking me about was this confounding variable. So it says, give an example of a possible confounding variable and how it might have affected your results. So a confounding variable is one that also has an effect on our response variable besides the actual treatment that we are testing. So in this situation, they're looking at, whether taking vitamin C every day is going to have an effect on the number of colds that people get. So what we notice is that people are choosing to either take vitamin C or not. They're not being assigned to it. So there could be some confounding variables that are affecting our final answer. So when we describe that, what we want to do is think of some variable. Maybe it's just overall health. Maybe it's just your immune system in general, something like that. But what we want to do is connect that variable, that confounding variable that we come up with, connect it to both our explanatory variable and our response variable. So for example, if I chose immune system, what I would want to say is something like, well, people who have better immune systems, it's probably because they take more vitamins. So they have more vitamin C in their system, so they have a better immune system. And people with better immune systems tend to get less colds. So it could be their immune system that has the actual result on the number of colds they get and not the amount of vitamin C they take. Something like that. You could say a number of other things. You could talk about just their general health consciousness, etc. But that is an example. You want to make sure and make that connection to both your explanatory variable, which is your vitamin C, and your response variable, which in this case is the number of colds. So we want to make that connection both ways, and then also make sure that you talk about a direction. So then part B asks us to design an experiment, and this is where it's just been a really long time since we've talked about stuff like this, so I wanted to go over it. So designing an experiment means you talk about how you're going to split your overall sample into groups, what you're going to have them do, how you're going to compare them, making sure to include randomness procedures. So one way we did this was with a diagram. So for example, it says 300 volunteers. The first thing I'm going to do is I'm going to split them into two groups. So I'll call it group A and group B. And group A I will assign to take a pill with 1,000 grams of vitamin C. And maybe group B gets a placebo pill. And then at the end, I'm going to come back and I'm going to compare the number of colds. We always want to be specific with what we're comparing. So never just say compare results, always say what you're going to compare. The other thing we want to make sure that we do is describe how we're going to assign them to groups, because it needs to be random. So this is where we would come down to the bottom and we would say something like, number each volunteer from 1 to 300. Use a random number generator to pick. There's 150 unique numbers from 1 to 300. The 150 volunteers whose numbers were chosen will be in group A, the remaining in group B. Something like that. You could also say place all 300 volunteers' names into a hat on slips of paper, mix the slips of paper around, pick 150 of them. Those 150 will be in group A, the rest in group B. You could say something like flip a coin for each volunteer. If you flip heads, that person is group A. If you flip tails, that person is group B. That is still random, that still works. The only downside of that, you're probably not going to get an equal size groups, but also it's very unlikely, but you could potentially get everyone assigned to group A and no one assigned to group B, because you could flip 150 heads, but that would technically be random. And then part C is asking to describe changes that might be if we wanted to block it for water intake. So that blocking means you separate your samples into groups before you even assign treatment. So you have your 300 volunteers. So blocking means I would say, split them into two groups based on water intake. So maybe high water intake, and then this one's low water intake. And you could talk through, what defines high and low, more than this much water per day, less than this much water per day. You could say the 150 volunteers with the highest water intake, 150 volunteers with the lowest water intake, something. You don't have to get super descriptive in that, but the point is we are separating based on how much water they take. And then within each group, we're going to randomly assign them to A and B, okay, which is the pill, the vitamin C pill and the placebo pill for both, and then we're going to compare the number of colds within each group to see if the pill of vitamin C made a difference within each group. We want to block it because we think that people who have high water intake may react differently or have a different number of colds than people with low water intake, so we're going to compare within each group. We probably will also compare overall, but right now we're testing the vitamin C. We're not testing water. We're just testing to see how the vitamin C affects those two different groups. So there you go.